All right, so this is the video slash class slash lesson over proportional relationships. That should say relationships. I forgot the S and I don't know how to go back and add it. So it's proportional relationships. All right, rather than type the rest of these notes, I'm just going to write them because I'll mess it up. All right. The reason we're doing a video on these notes is because it's something new, and a lot of kids have said that the videos have helped, and so I'm going to continue to try to make these videos anytime that I introduce something that's brand new. Okay? Now, in order to understand proportional relationships, first we have to understand regular relationships. A relationship is how two variables. What two variables do we use all the time?
X and Y.
X and Y. We always use that X and the Y. All right. And 99.9% of the time when we're talking about these relationships, we're going to use X and Y. Okay? A relationship is how two variables, X and Y, compare to each other. Yes, you can use any letters you want, but X and Y is the go-to. All right. So, when we discuss relationships, we talk about how X is affected by Y, how Y is affected by X, how they basically interact and compare to each other. Okay? So, relationships can either be proportional or non-proportional. So, since we're discussing proportional relationships, let me define that. A proportional relationship is when the ratio, all right, ratio is a fraction that compares two different things, of X to Y or Y to X is always equal. All right, I'm going to explain what that means because I know that doesn't mean anything to you yet. The ratio of X to Y or Y to X is always going to be equal. So let me give you an example. Let's say you have this table. We're comparing X and Y. You can, or you can just listen. It's fine. You have 1, 2, 3, and 10. Now, for the Y here, this would be 3, 6, 9, and 30. Now, if these were the numbers that were given to us, all right, this would be a proportional relationship, and here's why. If I took a ratio of X to Y, I know that's small, but if you look below, I'm making a fraction, putting X on top and Y on the bottom. I would get 1/3, 2/6, which what does 2 over 6 equal? 1/3. Then I'd have 3 over 9, which also equals 1/3. 10 over 30 is 1/3. Each one of these equaled 1/3. The ratio of X over Y always stayed the same. Now, up here I said it could also be Y over X, right? So you could say 3 over 1, 6 over 2, which would also equal 3 over 1, 9 over 3, which would equal 3 over 1. And in that situation, they would all come out to equal 3. Yeah, you could reverse them. As long as it always stays the same, it's proportional. Okay? So let's do this. Ooh. Oh, I can't do that. All right, let me...
How far can you hear the voices?
Oh, they heard that.
Yeah, you can hear all of them. If you watch the last video, you're yeah. Oh.
All right. So, when we have proportional relationships, okay, we talk a lot about the letter K. K is used a lot. All right, and here's what's weird about K. It does not stand for anything that starts with a K. I don't know why. They
Like
just
Kindle?
yes, like my name. It does not start with that. Instead, it starts with it represents the constant
That's weird.
of
Proportionality.
proportionality.
With a K. But it's not spelled with a K. Yeah.
The constant of proportionality. And here's what that is. All right, because I can already feel some of you going, what is that? All right. The constant of proportionality is what we multiply x by to get y. It's the number we multiply x by to get y. Okay, so let's say we had this table down here. I'm gonna put y on the top. Okay, let's say we have 25 and 5, 7 and 35, 8 and 40, and 10 and 50. What am I doing to x to get to y? Times 5. Every time I'm multiplying the x by 5 to get my y. Okay? So x times 5 equals y, so k equals 5. Make sense?
Yeah.
All right. All right, now you're right, it is. All right. Now, there's also a couple of equations we need to know. The main equation, you're going to have a lot of things that ask you, hey, what's the equation for this problem, this table, or this graph? And the way that you do it is you say, all right, for a proportional equation, it's going to be y is equal to kx. Okay, now, and if we think about that, y is equal to kx, we said that k is what you multiply x by to get y, right?
Yes.
All right, that's how we defined k just not 2 minutes ago.
Oh.
K is what we multiply x by in order to solve for y. So,
That's why they're right next to each
mhm.
other.
So a lot of times when you want to solve for one of these things, the only thing we really have to solve for is k. And here's how you solve for k. K is going to always be equal to y over x. You can pick any pair of x and y coordinates that are in that relationship, and if you put y over x and it's proportional, you'll get your k. Now, just so you can see it, here's a non-proportional equation. If I were to say y equals 3x, that's proportional, right?
Yes.
What was my constant of proportionality there?
3.
3, okay? So that's proportional. That isn't,
Plus one.
all right? You cannot add or subtract to the end and it stay proportional. Okay? All right. So, let's say, so far we've talked about tables, all right, where they give you this look here with numbers on top and bottom, top and bottom, top and bottom, right?
That's right.
No. So when we have this, again, we just put y over x, and if we constantly get the same answer, it's proportional, right? So now we can recognize proportionality in a table. Okay? Then we looked at an equation. Y equals your constant x is proportional. If they add or subtract anything, it's not proportional. So now we know tables and equations. The last thing that we need to know is graphs. And these are the easiest ones. A graph is proportional if it's linear.
Linear or linear?
Linear. What does linear mean? Anyone know?
Linear.
It's a straight line.
Who's straight?
I'm straight.
No, it's straight, that one.
All right. All right, so if it's linear, it's a straight line. Okay. And then, secondly, it needs to pass through the origin. The origin just means where everything starts. Okay? An origin is just 0, 0 on your graph. That would be the corner, right? It has to pass through 0, 0. If it doesn't, then it's not proportional. So, if we keep these two things in mind, let me show you how easy this is. All right. This graph right there, is that proportional?
No.
Yeah.
Is it a straight line?
Yes.
Does it pass through the origin?
Yes.
Then it is proportional.
Yeah.
All right. So that would be proportional. Now, what about that line?
No.
Why not?
It ain't right.
It does not go through the origin. This is not proportional.
And it's not.
All right. And then finally,
No.
No. That's the curve. That ain't right.
that's not a straight line. It's not linear. Therefore, it's not proportional. Okay. So, guys, those are all of our notes over proportional relationships.
That was fast.
Okay. So now we're going to go over a couple of examples here.
Is the
Okay.
thing stop going?
No.
No, it's still going.
That's some sick transitions.
I mean, it's counting.
That's legit.
Okay.
Oh, it is counting.
It's not counting down.
It's counting up. We're at 13 minutes right now.
What? Oh,
Yeah.
boxes.
Okay.
How are you?
All right. So let's go through some problems here.
Oh.
When do we
All right.
get the math book?
Don't even answer that.
All right. First one is a vocabulary problem. It says a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other is constant. Constant means it stays the same. So is it constant or not constant?
Not constant.
To be proportional.
It is constant.
Yeah, it would have to be constant.
Good job, Fabian.
Because we already said the ratio of y to x or x to y has to always stay the same. If it's always staying the same, that's what they mean by constant. All right. Now, if we're writing the equation of a proportional relationship in the form of y equals kx, then what does k represent?
Oh, wait.
Constant of proportionality. All right, that's something that we wrote in our notes. This is just kind of reviewing what we just talked about. So, yes, k represents the constant of proportionality. Why it's a k, I have no idea. All right. Now it says here, write an equation that describes the proportional relationship between the number of days and the number of weeks. Okay, so the first thing we got to do is decide what X is going to represent. Do you want X to be the weeks or the days?
The weeks.
Okay, weeks will be X, and days will then be Y. Okay, so if we want the equation, remember the equation is always done in Y equals KX format. All right, and how do we solve for K? Does anybody remember? Y over X. Excellent. So,
You gotta change them.
the only one that we know right now in this table is what?
7 over 7.
1 and 7. So, what goes on top?
7.
7. And what goes on bottom?
1.
1. 7 over 1 equals 7. Good. So, if K equals 7, then our equation here would be Y equals 7X. We just plugged in that 7 for the K.
Whoa.
As far as the rest of the table, we could say this is 14, this is 28, this would be 8, this would be 70. We just have to multiply the number of weeks times 7.
Oh yeah.
You did that with your
So hungry.
Did you say you so hungry?
All right, I'm going to pause this, and I'm going to let you guys try number 4 on your own.
That's why I started.
All right, so
Yeah.
if you haven't solved it on the video yet, I guess you could pause the video and try to work it out. But first thing you should have done is decide which one of these is X and Y. Okay, then you would have put Y over X to figure out your equation. Now, these are the two equations you could have gotten. Y is equal to 2X,
That's what I put.
or Y is equal to 1/2 X. Okay, you may have put 2 over 4X. 2 over 4 reduces to 1/2. Okay, and if you were trying to fill out the rest of the table, this would be 10, 17, 240.
What?
Because we multiplied by 2 here, so we'll do the same thing on the rest of them.
Oh. Okay. So which
Okay.
one's X and Y?
Well, you have to decide. If you said that this was X and this was Y, then you would have gotten this answer right here. Because you would have put Y over X, which is 4 over 2, which equals 2. Now, if you would have, on the other hand, said that this was X and this was Y, then you would have put 2 over 4, which would give you 1/2. So you'd have gotten this answer. So that's why I wrote both answers.
Are they both right or?
They would both be right as long as you labeled which one you decided was X and which one you decided was Y.
Yeah.
Oh, okay.
Okay.
Hey, Coach, you go for the Dallas Cowboys?
All right, now, number 5. Number 5 is a graph. The graph tells us which one is X because left to right is always X, up and down is always Y. So come up with an equation for that one.
Boom.
Okay, so if we're looking closely at this graph, again, we know that we're doing Y equals KX, and we know that K is solved by doing Y over X. So we can pick any of these points. I'm going to pick this one because it's the lowest. All right, I like using smaller numbers. So my Y that needs to go on top, remember the Y was the up and down. So my Y was 30. And my X was 1. So 30 over 1, which just equals 30. So that's my K. So now I can plug that into this right here, and I get Y is equal to 30X.
Why
we go.
did we do it from like the big numbers?
Okay, I got
If you were to pick the big numbers, you would have said your Y was 90, your X was 3, 90 over 3 still equals 30. So you would still get the same thing.
Oh, and the middle one too, you get the same thing?
60 over 2 is equal to 30.
Oh. I see you.
All right. Okay. Number 7. Looking at these problems right here, we want to look at the table. We want to decide if this is proportional or not. Okay. What two numbers are the easiest to compare to each other of all the pairs they give us?
0 and 32.
10 and 50 is really the simplest.
Yeah.
10,
How do you get from 10 to 50?
0 to 100.
Times 5. 10 times 5 would give me 50. What's 20 times 5?
2, 4,
That's 100.
20 times 5 is 100. Now, if this was constant, 20 times 5 should give us 100. It puts 68.
What?
Okay? So this is not proportional. Now, it asks if it's proportional. The answer is no. It's not proportional. All right? Because that ratio did not stay constant.
Oh.
All right? If you put 10 over 50, you would get 1/5. 20 over 68 is not 1/5. The ratio doesn't stay the same. It's not proportional. Another way you could tell really quickly, if it's a graph, it's a straight line, okay, and it passes through the origin. Now, what is the origin again?
Zero.
0, 0. Right here, it's 0, 32. So is that going to pass through the origin? No. When one of them is 0, the other one needs to be 0. So right away, I can tell, based off of 0, 32, that's not going to pass through the origin. It cannot be proportional.
That's easy. I
Okay.
get it. That's those more.
Okay, number 9. Number 9 is a word problem. It gives us a table. Now it says that Ralph is going to have a savings account and he's going to put in $100. And then every month he's going to put $20 in as a deposit. So we'll say money and we'll say months. Okay, so when he started the account, 0 months have gone by. How much money is in there? 100 bucks. After 1 month,
120.
20. After 2 months,
40.
all right. Sorry, you can't see that 1. All right. So is that proportional?
No.
No. For 2 different reasons. First off, 1 times 120 is 120. 4 times 120 is 240, not 140. So our ratio didn't stay constant.
Not proportional.
And then what's wrong with that picture right there?
I think 100. 0 to 100.
What is that not going to do that it needs to do?
Go to the origin.
It doesn't pass through the origin. So, this is not proportional because it doesn't pass through that origin. All right, the ratio doesn't stay constant. What could we change in this word problem so that it did stay proportional? So that it was proportional?
Put $100 in.
Don't put the $100 in. All right? If you don't put the $100 in, then your table becomes 0 months, he had no money in there yet. After 1 month, he had 20. After 2 months, he had 40. That is proportional. The ratios would stay the same, and you would pass through the origin. Okay.
It's the first one that's wrong.
Yes, the original problem is not proportional. If we took out the $100 deposit, it would be. All right, number 11 and 12. Let's take a look at how this could help us. All right, at first, I'm just looking at 11. Okay, so don't get confused when I'm writing this out. All right, I want to make the formula. Y equals kx. Now, k is solved by putting the y over the x. Now, these are the ones that we know. So, what's my y?
Or,
It's right there. Between
20.
commas.
20. Y goes on top, x goes on bottom.
8.
8.
So y equals 20 over 8x. Now, in your calculator, tell me what 20 over 8 is.
I got this.
I got a calculator. Dad.
I got you, fam.
Dad o'clock.
20.
2.5x.
2.5.
All right. So, y equals 2.5x. All we got to do is plug in 42 for x.
How do you plug that in?
Well, instead of an x,
Put a Y.
instead of x, I'll put 42. So in that same calculator, what's 2.5 times 42? 105.
105.
Now, 12 is a little different. Y is equal to, what's my y that I know? 8. And what's the x that I know?
12.
Oh, wait, what? Don't put the equal sign. All right. So I can still reduce this to y equals 2/3 x. They tell us that y is 12. So that would be 12 is equal to 2/3 x. To solve for x here, this is that last step of any algebra problem. We're going to have to divide by 2/3. All right, and that is a calculator problem. You would say 12 divided by 2/3, which would give you 18. All right, so that one's a little bit tougher because we have to divide by a fraction. All right, one more page. Okay. We're going to use the points in this graph to fill in this table. Okay, now, in the graph,
That's not straight.
distance. Is distance x or y?
Y. X.
Left and right is always x. Up and down is always y. So, my distances that they have marks for is 10, 20, 30, 40, and 50. My y, which is always up and down, is 1, 2, 3, 4, and 5. All right, we want to write the equation for this relationship. All right, again, we know it's y equals kx, and k is solved by doing y over x. So pick any point and put y over x. I'm going to pick the smallest. We said time is y and distance is x. So y equals 1/10 x.
Wait, how did you get 110? Oh, never mind.
Switch the time and the
Never mind.
distance.
Now this was y and this is x. Based off of the graph. Okay, so we want to know how long it would take to go 85 inches. Now 85 is our distance. That would be our x. So we would say y is equal to 1/10 or 0.1. Either one is fine. Times, don't leave, it's not us. Times x, which we just said was 85. And if you do that in your calculator, you'll get 8.5. There you go. Now that is our introduction into proportional relationships. We will practice this tomorrow. You won't have homework tonight, but you will have some classwork tomorrow to practice it.
Done.